Hi, AJ Hartley here, novelist, Shakespeare professor, fan of lots of things, including model railways, and I am making a series about the development of my all-Japanese N-gauge railway. This is the second in the series, and I wanted to talk a little bit about power supplies and points, turnouts, and then something specific to my layout, which is about the connection of two separate loops. So to start with, I should say that basically today, all model railways will run on any system, regardless of the difference in voltage between countries. So getting stuff from Japan isn't a problem. As I said last time, if you have a sort of standard power pack like this one, which comes with your basic model railway set, this has a little adapter on it, which will allow you to plug into any household electrical outlet. The Japanese system runs at, I think, 110 volts. The US runs at 100 and the UK runs at 230. But these little units will convert them down for you so that what you finish up with is what, 13.5 volts going to your actual track, and that's what runs everything. And of course, if you're not familiar with model trains, 13.5 volts is not going to do you any harm. So you can, when the system's running, you can touch the track and not get electrocuted or anything like that. The voltage is very, very low. It's perfectly safe. The other thing that I wanted to say is that there are two basically different operating systems that model railways use. So let me go back to my alter ego from a couple of weeks ago and a section that I didn't include in the last tape. There are basically two kinds of railway today. There's the DC system, which is what I grew up with as a kid, in which the power is controlled by, you've got a transformer like this, and that transformer routes power to the track, and then you control the track using the turnouts, using the points. The points will isolate the power so that if a train is going onto a track, you have to free up the power to get that train in, and then when you turn the point off, it isolates that track. There's no power going to it anymore, and that train can't move. That means you can then run other trains elsewhere on that same line. And that's a DC system. Now, a lot of people in the States today use what they call DCC, direct cab control. And this is a sort of computerized system which works differently. It means that the power goes to all portions of your track at the same time, but there's a little computer chip that you put into each engine, each locomotive, and then you use a separate controller which will allow you to control the different trains independently. In certain respects, it's a better system. It's a more modern system. But as with a lot of things in Japan, DCC has not caught on there. So because I'm using primarily Japanese equipment, I made the decision to stick to a DC system. That means that the only parts of the track that are getting power are the ones that are directly routed by my controller and by the turnouts. So in order to have two completely separate loops running trains at the same time, I would need to have two separate power packs. I could connect both loops to the same power pack, but then I wouldn't be able to control the trains independently. The one on the outside and the one on the inside would have to go in the same direction at the same speed at all times, right? I didn't want to do that, so I created a separation between those two loops and used separate power packs. So, as I said in that, most Japanese systems are DC rather than DCC. But one of the great things about the Kato track system, apart from its relative ease of construction and consistency throughout, is that when you buy a turnout or a point, in the Kato system, they have a couple of features. One is that they cannot be operated both manually and electronically. They're easy to connect up to you just run a wire underneath and plug it into the accessory section of your power pack with a separately purchased switch, and then you can control it electronically. And it's a nice, clean snap control. It doesn't make noise, and it's not super expensive in the way that electric points used to be when I was a kid. The other thing is that if you flip the point over, you'll see these recessed screws, and those can be used to determine, you can just adjust them as to whether you want the point to insulate the turn off or to allow access, power access at all times. So effectively, even though I'm doing a DC layout, these points on the Kato system can easily be adjusted to operate with a DCC system. Now, points are more expensive than track because they have moving parts and they're intricately made. For the most part, they're about 20 bucks. I'm going to talk a little bit today about a more expensive piece. This is actually the most expensive piece of track I have ever bought, probably. It's about $70, but it gives me the capacity to do something that I really like. As I said last time, I've created 2 separate loops, each one controlled by a separate controller. But I want to be able to move between those loops. So I can put a point that will allow them to connect at some point, but if I only have one point, then that means that the train has to be going in a certain direction in order for it to work. Or I'd have to go through the point and then stop it and reverse it, having changed the point to move it around. What I really like is this. This is a crossover point which allows me to change both tracks regardless of which direction the train is traveling, which allows you to route from one loop to the other. You have to maintain speed and direction with both power packs as you do that, in order so that as the train leaves its current power supply and picks up the other power supply, that there's no discrepancy between the two. If it's going forward and the other power supply is going in reverse, that's immediately going to short the circuit and it's going to stop the train. Or if one is going a lot faster than the other, that's going to be a problem as well. So you maintain, at the moment when you want to use the crossover, you need to maintain the same speed. But as soon as you isolate the 2 tracks, they are completely, by throwing the point, they are completely separate. You can then do with them whatever you like. This is a $70 piece of equipment. As I say, it's the most expensive piece of track I've ever bought. But I had a gift voucher as a Christmas present, and this is primarily where it went, and I really like it. That's all I'm going to say for now. I want to keep these fairly short so that people don't get overwhelmed. So as ever, please like, comment, subscribe, check out my books, my merchandise, my Patreon page. Thank you to all my patrons who make this kind of thing possible. And if you have questions or particular points of discussion that you want me to raise while I'm talking about the railway stuff, let me know in the comments and I'll try to factor that in to future videos. All right, that's all for now. Thank you. Bye.